Hello everybody. I'm going to go through the proof that I assigned for homework, and I forgot to put that's a P and that's a Q. So this is a traditional type of algebraic proof because, one, we're in a coordinate plane. So since we're in a coordinate plane, there's a C in there. Coordinate plane. This is going to lead us to what we call an algebraic proof. Wow, this is bad. Well, it's not even 9 o'clock. I'll white it out. I'll make it better. An algebraic proof is just using formulas, using not only the characteristics of the shapes, but using formulas like midpoint formulas, distance formulas, Pythagorean theorems, such like that, to solve our problems and to come up with what we need to do here. Now, one, we're told that triangle ABC is isosceles, and we're also, that's isosceles, and we're told that AB is congruent to AC. So I know, and we know, that this segment here is congruent to this segment. The nice thing is we can draw all over it, use different colors. I got a red, I got a blue. I'm sure I got some more colored pencils somewhere here. Maybe not, but that's okay. But drawing and labeling the shapes are absolutely important, and we're going to spend time when we come back from Thanksgiving taking care to make sure that we actually are able to do this. Now, what we're trying to prove, and I'll highlight these in blue, is that the length of PC, or PC, that segment, is congruent to QB. So, in order to prove this, to prove that PC, the segment PC, is congruent to QB, we need to show that the length of PC is equal to QB. And we're told some key pieces of information. One of them is P is the midpoint of AC, or AB. So if P, and I'm going to use a flow chart because I think the flow chart's really good. P is the midpoint of AB. Alright, so there's our first part, and that's a given. So we'll put given as our statement underneath it. Now, what that tells me that I can use the midpoint formula. So the midpoint formula says, that's A. The midpoint of AB is, coordinate plane. A coordinate is not equal to anything, but the midpoint is going to be, you take the two x's, 2a, plus 0 divided by 2. And then you take the two y's, 2b plus 0 divided by 2. And we'll get 2a over 2 and 2b over 2. Or not 2b, which is ab. So P actually has the coordinates AB, and if we just kind of circle this whole thing, we get a midpoint formula from there. Let me zoom out a little bit so we can actually see some stuff. And try to make this a little bit nicer. Now, so that's one. Since we have some interesting space that we're dealing with, I know that Q is the midpoint of AC, and I'll say that's given. And we'll do the same thing. We'll use the midpoint formula. So the midpoint of AC will be, add up the x's, 2a plus 4a over 2, and add up the y's, you get 2b plus 0 over 2. This is going to be 6a over 2, that's 2b over 2, which is 3a comma b. And so Q is at the point 3a comma b. So if I want to go back to the original paper here, that's 3a comma b, and this is a comma b. So now I'll go ahead and circle this and say it's the midpoint formula, because now I have coordinates for all my points. And since I need to show that the two distances are equal, I need to use a distance formula. So let's use a distance formula. And so step 3 would be PC is equal to the square root of, alright, we're going to take the difference of the x's. Now, one thing that I like to do is for PC, I like to go x comma y and say, alright, that's a, b, and then that's c is, so that's p, that's c, that's 4a, and that's 0, and I have to subtract, so I get negative 3a, and that's b. So I'm going to take negative 3a, I'm going to square that, plus b, and I'm going to square that, so PC is equal to the square root of 9a squared plus b squared. Alright, so I know that's what PC is going to be equal to. Now step 4, I need to figure out what QB is going to be equal to. That's going to be another square root. So I'll make another chart. My XY, I'll put Q and I'll put B. Q is 3A, B, and B is 0, 0. Subtract that, 3A and B. Now if I take a look at, here I get 3A and B, I got 3A and B, they're the same. So that right there is telling me, alright, well, when I start plugging them in, I should probably get the same stuff, but let's check. 3a squared plus b squared. So QB is equal to the square root of 9a squared plus b squared. Now, if I take a look at PC, which is the square root of 9a squared plus b squared, QB is equal to the square root 9a squared plus b squared. They're both equal to the same thing. So I could say that from here, PC is equal to QB, and I could say that PC, the segment, is congruent to QB, which is QED. And reasons, this is the definition of congruency. This is, you could do a substitution. This would be from the distance formula. If that's step 5, I could say 3, 4, and 5 is all about distance formula. And so 1, 2, we find our midpoints. Then we use our midpoints to find the distances. And once we find out that the distances are the same, we find out that the segments are the same. And voila, QED, we have proven what we needed to prove. So this is a nice formula, or a nice proof rather. Pretty straightforward because threw my pen, sorry. All we used was two formulas from chapter 1. Distance formulas, midpoint formulas. You can't get away from that stuff. And it's all right there. So let me well, that's not the best picture on the planet. Maybe this will help. That looks better. There's the proof. And hopefully you were able to get that.